Hello students, today's class we will be discussing about water. This is third chapter in class 9 ICSE, and in this chapter we will be talking about properties of water and various uses even of water, purity of water, hardness and all. So let us begin this chapter, start discussing about water and its chemical nature. So we will start this topic, water. You all must be knowing that molecular formula of water is H2O. Molecular formula is H2O, and it has certain properties. But basically, first topic in your syllabus, it starts with water cycle, basic idea. Suppose you just imagine that this is land mass, mountains and hills. Let us assume that this is water bodies. So when clouds rain, we get rainfall. They are washed to sea or water bodies, and from there they evaporate. So first part, this is called precipitation. That is when rain clouds get laden with moisture, enough moisture, they start precipitation, that is called rainfall. Now once the water is collected, it may evaporate from the surface and it rises up and gets condensed, that is condensation, and forms cloud. These clouds again they will rain. So this is cyclic process that we can see here. This is the basic fundamental. This is not that exactly the figure will help you to understand everything from whatever sources. Like for example, plants and all, they transpire and they lose water in the form of water vapor to the atmosphere. They also help in the formation of cloud. I have not drawn here, but I have just shown that evaporation takes place, and at higher altitudes water vapor gets condensed to form clouds. So this is the basic idea of water cycle, and we will be talking now about physical properties of water. Physical properties of water. First one is best thing you should know that potable water, if you take, potable water means the water which we can use for drinking. Basic features, what all things it should have: it should be colorless, it should not have odor, odorless, it should not have any taste, tasteless. However, minerals, if present, minerals provide taste. Means if you find water to be tasty or of some other taste which you may not like, even it is due to the presence of mineral salts present in them. Another one, it should be free from microbes. It should be free from microbes. These are basic features that potable water or drinking water should have. Anyway, let us discuss now about boiling point of water. boiling point of water. Boiling point of water. How do you define boiling point? When you start heating, suppose you just imagine, to get the clear concept, suppose you just imagine that this is sea level. This place is sea level. So at sea level, what pressure we experience? That is 760 mmHg. That is the normal pressure of atmosphere we have. So at this point, let us imagine that we are heating, or in those areas where sea level is almost zero, altitude is zero. So in such places, such areas, if we start heating water, we will find that pure water will boil at 100 degrees Celsius. That is boiling point. So what should be the definition of boiling point? Boiling point of pure water can be defined as the temperature at which water boils and gets converted into vapor. So pressure should be normal atmospheric pressure, that is about 760 mmHg, or which we call it 1 atm, or even 76 cmHg according to barometric liquid, that is mercury. Now, second point. Before we go to second point, there are some region-based questions that why it is difficult to cook food at higher altitudes. You must have heard, like in India, in hilly regions, when they boil rice, they cover the container completely. Even they try to pressurize, putting some bricks on the lid of the container, if they are not having pressure cooker. But if they have pressure cooker, it is well and good, because pressure cooker is there, and once we start heating, that pressure increases the temperature inside the pressure cooker, and therefore cooking becomes very easy. Now, why it is not possible to cook at higher altitudes? Let me tell you. This is asked in your region-based questions, so you have to understand. Just imagine that you are living in this zone. So if you start heating water, and you will find that it may boil even at 70 degrees Celsius. So it becomes difficult to cook. So at higher altitudes, we can write here that at higher altitudes, water boils at very low temperature, let us say about 70 degrees Celsius. Hence, not enough for food to get cooked. Therefore, food cannot be cooked. So this is the disadvantage that we have at higher altitudes. At low temperature, because of low pressure, water boils and food will not get cooked, or even it may take very long hours. Perhaps the food may not turn to be tasty also. Next one, we will be discussing about freezing point of water. freezing point of water. Oh, you must have seen, suppose if you keep water in a bottle and keep it in refrigerator, you will find when temperature start falling, you will find crystals of streaks of ice in water bottle, and slowly the whole entire mass of water in a bottle gets frozen. But at what temperature it starts, this part is very important for us to understand. If it is pure water and at normal atmospheric pressure, let us say that is 760 mmHg, water freezes at 0 degrees Celsius. Therefore, freezing point of water is 0 degrees Celsius. Next one, density. Next property of water is water's density. We will discuss. Density means you must be knowing mass per unit volume. If it is pure water, then it is pure water's density is about 1 gram per cc. It is 1 gram per cubic centimeter. But here we need to understand that anomalous expansion of water. This is very, very important topic. Anomalous expansion of water. Anomalous means, in general, most of the liquids, when you increase the temperature, density decreases. But here in case of water, it is little different. How it is different? Let us understand with the help of graph. For example, you take density in terms of gram per cc and temperature in degrees Celsius. This is y-axis and this one is x-axis. In case of water, what we find, that graph would be this way. At maximum, we find at 4 degrees Celsius, density would be 1 gram per cc. So, if you decrease the temperature below 4, again you will find that density decreases. And if you increase above 4, again density of water decreases. Therefore, it is called anomalous in both the sides. Above 4 degrees Celsius or below 4 degrees Celsius, density of water is always lower than at 4 degrees Celsius. Therefore, it is called anomalous expansion of water. We will discuss here an application how anomalous expansion of water is useful for aquatic plants in very cold areas where the surface of the lakes get frozen. So for this I am just writing life under frozen lakes, how they are able to survive. Imagine that this one is lake. What happens? Surface temperature, when atmospheric temperature is falling, when the temperature of atmosphere is falling, below 0 degree Celsius, surface water of the lake gets frozen. Once it gets frozen, then this frozen surface acts as insulator. So this insulation of frozen surface will not allow further cooling. Therefore, the lower surface or the bottom of the pond may have 4 degrees Celsius. It may be 0, it may be 1 degree, it may be 2 degrees Celsius, it may be 3 degrees Celsius when you go towards the bottom of the pond or lake in very cold areas. Here, anomalous expansion, how it is useful. Very simple. First, try to understand. When temperature starts falling in that area, temperature of water, let us say, starts falling towards 4, so the liquid becomes the densest form, so it will go to the bottom, and the very cold liquids are or the water is lighter, so it will try to remain on the surface, and slowly once it is frozen, its density is much lower than water at 4 degrees Celsius. Therefore, it will keep floating and it will shield the surface of the lake, preventing further cooling of under surface water. Therefore, life can exist. Fishes and all will continue to survive even the surface is frozen. I hope you have got it, how life is possible under frozen surface lakes. Next one, latent heat of fusion of ice. Latent heat of fusion of ice. Definition says it is the amount of heat required to change the substance from solid state to liquid state at its temperature without any change in temperature. So let us learn. Suppose I have taken here ice. If I have taken ice and if I try to heat, let me say I have placed even here thermometer. This one is thermometer. These are ice. I have started heating. Once I have started heating, ice particles will gain heat energy. Means the heat which I am providing, they are gaining those energy and getting converted into water form, liquid form. So it will be easy for you to understand if I write this way. If ice is taken and let me say temperature is 0 degrees Celsius, but I have heated to some extent, so it got converted into water, but still the temperature remains the same. So the heat which is required here is called latent heat of fusion. Means there is change in state from solid to liquid. State is changing but temperature remains the same. So we can say that at a fixed temperature the state of matter changes and the amount of heat energy provided to that So here we are having solid to liquid. So this process of conversion is called fusion, and the heat energy that is required to convert solid into liquid without any rise in temperature is called hidden heat of fusion, and that hidden heat is called latent heat. Now question arises, where is that heat going? Where is that heat going? This heat is getting used up, breaking the bonds holding the molecules together, means ice molecules are compact, let us say. To break those molecules slowly, certain amount of heat energy is required, so that heat energy supplied to change the state of matter we call latent heat. But you have to keep in mind, unless particles start vibrating, there is no rise in temperature. So only to change the state of matter, the heat supplied is called latent heat. It is not exhibited in the thermometer with rise in temperature, so we call it latent heat. Next one. Here you have to understand that if you take like 1 gram of water, if you take 1 gram of water, 1 gram of ice if you take, and you try to convert it into 1 gram of water. You have taken 1 gram of ice, you are converting it into 1 gram of water. Let us say temperature is same. So here how much energy you will require, this part you should know. 336 joule per gram, means for 1 gram we are using, so I have written here 336 joule per gram, or it is written in terms of calorie, 80 calorie per gram energy would be required. So I hope you have understood latent heat of fusion, that is melting. Now similarly, it is very easy for us to understand latent heat of vaporization of water. Latent heat of vaporization of water means, let us understand, if you take 1 gram of water, and let us imagine that temperature is 100 degrees Celsius, or another value we may put. Let us say 100 degrees Celsius only, and if it is changing into 1 gram of vapor and temperature remains same, so amount of heat energy required will be called latent. Since I have taken here a specific amount, so we can call it a specific latent heat of vaporization. And this value is 2268 joule per gram, or in terms of calorie it is given, or we can say 540 calorie per gram energy would be required to convert 1 gram of water into vapor form without any rise in temperature. Always keep in mind, change in temperature is not there. temperature remains the same, only there is change in state of matter. This is what is very, very important for us. Next one, specific heat capacity. These are important terms that you are learning, and very, very important in region based questions and application based questions from this properties of water. A specific heat capacity. A specific heat capacity. This one you should always remember the definition: the amount of heat energy required to raise the temperature of 1 gram of water by 1 degree Celsius is called specific heat capacity. Let me say, you have taken 1 gram of water and you have started heating. Let us assume the temperature is 14 degrees Celsius and you want to increase the temperature up to 15 degrees Celsius. So the heat energy required will be called a specific heat capacity, and value is 4.2 joule. So here the specific heat capacity of water is 4.2 joule. 4.2 joule per gram per degree Celsius. Means to raise the temperature of 1 gram of water by 1 degree Celsius, you will require 4.2 joule of heat energy. Means we can say that a specific heat capacity to raise the temperature by 1 degree Celsius of water is very high. That's why it is used as coolant, and it can moderate the climate. You may be feeling very hot in hot summer, but if it rains just after rainfall, you find that weather has become moderate, because almost all the heat energy, not all but most of the heat that was due to radiation is being absorbed. Okay, so here we cover up the major properties of water, and I hope that you have understood, and we will continue with the next topic of this chapter in our next class. And thank you being with me. Thank you so much.